like our points, because I don't know how like I think it's just like when you will speaking, it just like will look at you like not on the screen or
Okay. So
like will be like some problem, just like they will text me and I will fix it.
Okay, and when can I start?
I think now.
Can I start?
Yeah.
Okay. So, good afternoon, everyone, and welcome to our meetup. So today we will speak about unit testing using Google Test and applying two specific standards, ASPICE and ISO 26262. Let me present myself. I'm Luis from Porto. I'm master in electronic engineering and computer. I have 8 years of international experience, ISTQB certified. My role currently is lead tester in Andersen company, and I have experience in automotive, energy, and health kitchen industries. So this is my background, and this is the main points about me. And without wait more, let's look to the presentation. So the agenda for today, I will give you an overview and introduction about unit testing, then some fundamentals about that, ASPICE, a practical case study of a project that is applying using ASPICE with what tools, what kind of cares you need to have, some details, some connection between the tools and other things, ISO 26262, Google Tests overview, and in the end we will finish with a real practical example, put the hands on the job about these two standards in Google Tests. So let's start for the introduction. So nowadays the market of automotive, there are a lot of projects and a lot of brands that are developing according to the challenges that we have. Basically autonomous driving, electric cars, so are industries that are changing and the challenges will be more and more. So based on that, process quality, critical safety are really important points to be different for different brands. So it will bring us market value, because if you follow high quality standards, our value in the market as service providers will be bigger than the others. And of course, unit tests is the point of our presentation. So start speaking and explaining as overview about the unit tests. Basically, it's to test in isolation. So we got one piece, one component of our project, let's say, can be a function, and we will test it isolated. You can see here the source code with 1, 2, 3, 4, 5 functions, and we got one of them, put them isolated, and we will test how it works. So it's used to ensure if the code works correctly, and it's focused on functions and methods. So it's the first group of testing. Then we have software E5 and 6 according to the model, but now we will focus on the software E4 unit testing. As you know from other theories from testing, but it's important to refer how important is test early. And unit testing allow us to do that because it's the first level close to the code. So it can be done by developers or testers, depending on the project approach. But the point here is understand how expensive is detected defect in the future. You can see in the requirements architecture phase, the cost is so slow. But if you look for the production or post-release phase, it's really expensive. Here is focus the importance of unit tests and why we need to focus on that testing level and why we need to put high quality on this phase. Because if we found a defect on this phase, we save a lot of money and a lot of time compared with the future levels. Here we have some important points to refer, that it allows improve the code quality, because when we are developing the code and the unit tests allow us understand how can be improved or some parts of that code, bad implementation, misunderstandings and things like that. Reduce the technical debt, add new features more easily because we are implementing and at the same time we are testing, or if we use the TDD first test and then the implementation. But to simplify, just keep on this way, so we implement and then we test, and we are really close between the implementation and the testing phase, and fix bugs efficiently. Here are some popular frameworks for testing. We have JUnit for Java, Google tests in C++, PyTests for Python, and MES test and unit in C#. So the focus of this presentation will be Google tests in C++, but the logic is more or less the same with the other frameworks. So let's start for unit testing and ASPICE. So ASPICE is a framework for assessing and improving processes in automotive industry. So there is a known word in the world of projects in Europe and other places about automotive, and it's a standard that focuses on the process of testing. Basically, what we do for test from the beginning until the end. It includes documentation, rules, etc. It allows us to have high-quality software delivery, at least help us to do that, compliance with industry standards, and continuous improvement of the processes. Here is the, let's say, organization of the V model. It's only to explain to you that ASPICE covers a lot of areas in the same company. Here we can see risk management, we can see here security, documentation, suppliers. But we will focus here on the middle, where we have the V model and where you can see software 4, 5, and 6. Unit tests, integration tests, qualification tests. And this presentation will focus on the level 4. This is the table that the document, updated document of ASPICE present to us. So basically, we have here the best practice recommended for them. This document works like that. So don't give you, let's say, a guide really detailed how you have to do, but give you a high-level description of the best practice. And then you need to derive measures how to fill this best practice. Okay, we will see soon some examples. I only want to show you that they give us 5 best practices for unit testing, and then let's look one by one what it means in practical way. So the first one is this. I will not read because it's collected from the official document, but basically the title says specify software unit verification measures. What it means, you should have verification measures, and can be things like that, pass and fail criteria, when you can say 100% of unit test cases have expected results. We have code coverage bigger than 95%, are some examples like that. We are speaking about pass and fail criteria. The same about entry criteria, exit criteria, infrastructure. So we have different measures to verify each point of that. This is requested by ASPICE. I put here that examples, but could be others. Okay. The important thing is say, okay, we have this ASPICE best practice recommendation, and based on that, we derive measures, metrics, documents, whatever, to make sure and show that we are matching this best practice. And this is one example. Another one is about select software unit verification measures. So what we will select, we can see here the percentage of code coverage, for example, defects detected in previous releases, requirements coverage, critically of affected models. So all of that different parts can help to match this best practice, and we have the regression test strategy. So how we will run our regression tests. Why? What criteria? Every day, every week, every night, what we expect to have on that, all of that things must be defined according to ASPICE in our test documentation. The third one is verify software units. So in this case, it's itself test and verify, and you can see here different things that we can be done. Static and dynamic analysis. So here we can speak about static code analysis, for example, using MISCA. Code reviews. ASPICE also recommend do code reviews. For example, I implement my test script and I deliver that. My colleague do the review, approve, pass, fail, I rework, then send it again. This is a procedure recommended for them. And of course, unit tests to validate the units using the framework, in this case, Google tests. Here, one interesting, one of the most that I like, honestly, this is about the traceability and about bidirectional traceability. What it means. Basically, in the different artifacts, you need to know what is covering or matching what. let's look to the example. I have requirements, and I need to know, okay, what are the test cases that are validating this requirement? And through naming convention, for example, the name of the requirement in the test case header of the table, when we have the test specification, we can have one field on the specification called requirements validated. And I have 1, 2, 3, 4, 5, 6, 7, 8, 9 with the ID of the requirements. And I cover this situation. The same here about naming convention, I can have the test script with the same name of the test specification. The reverse can be done. In my code, I can put a comment or something like that with the link of the specification of this script. And it allows us knows all of that traceability. Basically, in any place that we are in the code, in the specification, requirements, or result, I can access and know tracking the requirement specification script and result only looking for the artifacts without more information. And this is another requirement from ASPICE. Another one is summarize and communicate results. So it's understandable in general. So basically the test reports and test summary should be well defined. What fields we should have there, what metrics, and have the template documented and have it ready to communicate the results to the stakeholders of the project. And that are the 5 best practices from ASPICE, of course, derived in some practical cases. Here is a project where we applied ASPICE. So basically, in terms of process, we follow the V model. We have Kanban and Scrum, but the ASPICE can be seen here. We use it Doxygen, where we have the detailed design, what it means, some kind of diagrams about the units that we have, where we explain what the unit should do. In this case, let's say the requirements or the specification. Then we have the Rhapsody with architecture of the code to understand the interface between them. And in the end, ALM to put the test specification and conduct the test script. So some tools are involved here. Some projects can use less tools than that. But this is a complex one with a lot of tools and how the traceability is done. Also, official tool for review. Basically, when we implement that processes, we have to have formal reviews for specification, script, and results. Of course, it's for apply ASPICE 100% for level 2. So now let's look to 26.26.2. It's related with functional safety in automotive industry, and it's related with electrical and electronic system in road vehicles. So recapitulating ASPICE about the process, ISO 26262 about functional safety. And the object is ensure the high quality software delivery, maintaining compliance with safety-related industry standard, and promote continuous improvement and safety. So related with safety is the word. Here, I got this part from the document, official one. Basically, in this section, we have part 6, section 6 to 9, and for unit testing, we have 3 parts: methods, test case generation, and coverage metrics. ISO 26262, in my opinion, is more objective than ASPICE. While ASPICE gives you the best practices and you derive things from there, ISO 26262 give you more direction. Let's say, give you, okay, use this. I recommend that you use this thing instead of that. And you will see 1, 2, 3 tables, and we will look for all of them. First one is about methods for unit testing. So we have different levels of ASIL, okay? Depends on the security level. ASIL A is the less secure, let's say, less critical safety. ASIL D is the most critical safety. What it means? If we are in the project that we want to match ASIL A level, ISO 26262 recommend a lot requirement-based tests. Okay, recommend a lot interface tests, but fault injection, resource usage test, and others are optional. You only do if you want. Okay, but for ISIL D, critical safety maximum, all of them are absolutely recommended. And indeed, these different ways we can classify the project in different ASILs. The same thing about how derive my test cases. I'm looking to my unit, to my code, and I need to derive it. I will use equivalent classes, boundary values. What should I use? And ISO 26262 helps again. We can see ASIL A, where we have I recommended analysis of the requirements, but the others are not mandatory. Look, boundary values, equivalent classes, error guessing, optional. Okay? Requirements, test requirement, that's okay. No error guessing, nothing more. But for ASIL D, critical safety, they recommend all of them again. Okay? And here the same. What metrics should we have for our code? Statement coverage, branch coverage, and MCDC. And basically for ASIL D, more recommended, ASIL A, less than it. And in general is this, about ISO 26262 for unit testing. Now let's look for Google Tests overview. Basically, remember, it's a framework to test with C++, and we can identify here in general 4 things: test case, test suite, assertions, and features. So test case is not more, not less than one piece of code like that, where we have the test itself. So we are doing some things, for example, check if 2 parts add 2 numbers, 2 plus 2 equal 4, or something like that. This is the thing that we have here: addition, subtraction, multiplication, and division. One test case for each one. So it's only to understand the concept in terms of Google tests. A test suite, look, we have here the test cases, but here we have a test suite. It's called, let's say, a group of tests, okay, that share the same characteristic or some environment, let's say. We have simple operations. Yeah, I have a test suite that it's called tested operations, and for each one of them, I have one test case to check the addition, another to the subtraction, multiplication, and division, but all for the same main simple operations. Assertions. So you don't need to know all of them. It's only some practical examples, but basically are some kind of macros, let's say, to check results. For example, this one, assert true and put the condition inside. Here we have expect equal, and we have here the result of this operation, and here the expected result. And this framework will give to you the result in the end. Say, okay, it's okay, test pass. It's not okay, test fail. You can see here other variations of that. You can check exceptions. You can set floats. We can check floats. You can check if the value is bigger or less than other reference or something like this. So you can compare a lot of things. Of course, are only here some of them, and it can be explored more and more. So another important part of that is about features. What it means. There are a class like this, where we have the setup and the teardown. What it means practically. We have the setup, then we will run the test case, then we will run the teardown, and it in cycle. What it allows, clean the data or set data before and after each test case. It's useful to keep the test case independency and helps a lot to set and define specific values for a specific test case. It's a bit more advanced, but I guess it's more or less understandable on this way. You can see how it seems in the practical case. We have a class, calculator test, that it's here, feature, yeah, and it's not being done nothing here on the setup and teardown, but we can put, for example, if test case equal 1, 2, 3, set the value to 10 and validate the specific value. Now, some best practices using Google tests. I put here using Google tests, but some of them can be applied in all kinds of tests, okay? So the first one is test early. So I guess a lot of us understand what it means, but here test early is more about test early also in terms of automation. Try as soon as possible have automated pipelines in Jenkins or something like this to allow anytime we add some improvements, some implementation, know exactly what the status of the code and what impact the change had in our code. Another thing is about test one thing at a time. Sometimes in some projects I saw a lot of people trying to test a lot of things without some kind of criteria. So the recommendation here is organize the things by blocks, by characteristics. Let's say, for example, positive numbers, negative numbers, floating point numbers. For example, instead of mix all of them and create some kind of confusion and hard to understand the test itself. Another important thing, keep it readable and maintainable. What it means, looking to the practical case, we can have this description, test 1, 2, 3, or we can have something like that. Handles overflow on addition. Practically, in terms of code, practically, it don't change nothing. It will run, we will have the test results, everything will go fine in both cases. But I guess everyone agrees that if I look for the left side or the right side, it's absolutely more easy for me to understand what's happening there. If I read this, then test 1, 2, 3. Test 1, 2, 3 don't means nothing. Okay? This handles overflow on addition, at least gives me some information about that. So keep the test independent, as I referred before, using the same structure. Setup, test case tear down. It's using the class for features. And as I told, it's really important to keep tests independent, because sometimes in some projects we update one test case, and imagine one test case is failing, you update it, and then you have 5 test cases failing. So it means that they are not independent. For example, if you have a global variables in one, clean the global variable in the end. If you need to set something, clean in the end. Release memory and things like that. Keep them completely independently. It means leave the room as it was. You enter the room, test, clean, leave the room is as it was. Okay? So mock external dependencies, it means then when we are testing a function that is using functions from other models or component, we will mock them. For example, look to this function that we have is calling the function 1. Of course, I will not validate this function because my scope is this and not this. I will mock. What means mock? Replace the content of this function for something that I want to simulate. In this case, return true. But could be return false or can be return some number. It will allow manipulate the different functions calls inside of the same function to decide to manipulate and create scenario specific for that situation. So then use the assertions wisely. So here is a specific point that are 2 types. Basically, in one type, when you are running your test, check it, check it, check it. It fails, stop and leave. And in another case, it continue running, but the test will fail. So the recommendation here is verification fails, stop the test, because it's not needed to avoid time running the other verifications. This is the main point on that part. And avoid complex logic in the tests. Understand that sometimes use some kind of loops, some kind of more efficient processes is better in terms of performance, and the code, they put the code smaller, but sometimes it's better to have more code but more understandable, more easy for someone that comes from outside, a new team member, something like this, join the project and easily understand it. Another thing is about the debug. It's absolutely more easy to debug something like this than with for and while loops and things like that. I'm not saying to don't use that. I'm saying that to be sensible, to understand when makes sense, use one approach or other approach. It's not one is right, not another is wrong. It's nothing about that. It's avoid complex logic not needed. Okay. For example, in this case, why I'm doing this while, if with 4 or 5 lines I can do that, something like this. Okay. And then the code coverage. So in Google Test, we use Gcov to generate the coverage, and basically we have something like that. When we can look to our code, green, the lines where we pass, red, the lines that are not covered. And in the end, we can have some kind of report like this, where we have line coverage, how much functions tested, how much functions we have in our file, percentage, everything like that. So important to generate the coverage, look for them, and analyze also the results. So now we will start doing a practical case, okay? And I will explain it to you first, and we will apply ASPICE, ISO, and some good practices, okay? So first of all, it's important to understand what are we doing. Our practical case will be test this function. You don't need to know C or C++ to understand it. Basically, this is a function that calculates the square of a number if it's between 10 and less 10. Imagine, I give 5, the function gives me 25. I give 3, the function gives me 9. I give 20, the function gives me 99999 because it is out of range, and 999 we will consider error code. Okay, everyone understand well what are we testing? Clear? Nice. So basically, this is the input that we can have to test. So I understand that sometimes the developers don't have time or don't have the practice to create the documentation about the code. Sometimes we need to base only on the code, only on that. Honestly, it's not the best approach, but it's more often than expected. Another way is look for the requirements of the function. We can have something like that. What are the inputs? What are the outputs? And some kind of flowchart. Okay, start, insert a number. The number is valid. Let's say it's between 10 and less 10. Okay, if yes, returns the square and n. If no, returns error and n. Only with that, we could be able to create our test specification. But I put here 3 different examples of things that can be used as input of our test cases to derive that. So let's apply the first one. ISO 26262 requirement-based testing. So we have the requirements that says, okay, if I insert a valid number, returns the square. If I insert the wrong number, returns error. Done. Test case 1, insert 5, receive 25. Insert 200, receive error code. I cover the requirements. Correct? It's applied ISO 26262 first table 10 line 1. Then let's create my test cases. Okay? Analyzing the requirements. This is exactly the same that we did in the previous slide. Okay, I copied and paste here. But they say equivalent classes, boundary values, and error guessing. So equivalent classes, less 10, between less 10 and 10, class 3 bigger than 10. Boundary values, less 10, less 11, less 10, less 9, 9, 10, 10, 11. And error guessing, a big, very big number and a real small number. It's clear for everyone the creation of all of that test cases. So, and we applied the 4 lines of ISO 26262 to derive that test case. So then, let's implement them. It's the code, real code, okay? And the requirement analysis is here, 5, 25, 200, 999. Equivalent classes I got from here to here. Boundary values from there to here. And error guessing here. Is it understandable, the match between the 2 parts? Okay, so basically I apply the ASPICE, the ISO 26262 in 2 phases. Now I implemented the code. By now I did nothing more. So now it's time to apply some good practices, okay? Instead of have all of that tests together in the same package, in the same thing, test 1 and things like that, what we did, we divide it in 2 parts, okay, with a test suite called square tests, and we have positive valid values, negative valid values, and invalid values. We didn't nothing more than got it, this confusion, and split in 3 parts. The test cases are exactly the same, okay? And put maintainable. Instead of test 1, we have positive, negative, and invalid. Use the assertion. So instead of expect equal, we switch to assert equal. What it means? My test start running here, it fails, jump outside. In the previous one, if it fails, it will continue executing the rest. Okay? So next one is about the assertions, yes, and here we have the case of the tear down and the setup, basically using this class and applying this to clean or not the test. And in general is this. I have here a video just to show to you how it seems in the VS Code. Give me just a second to put the mouse on that side. And it seems something like this. And to run it, I go to the command line, put the executor, and I have here the result of the Google tests. That are the tests that I show to you. You can see here the negative values, positive, invalid, and here we can see positive values running. Okay, everything passed. Negative values running. Okay, pass it. Okay, pass it. And it all seems Google tests in VS Code. Okay, so based on that, I open the space for questions.
Yeah, I have a question about the time, because the case that you showed, it's quite easy, yeah, meaning the assertion and the equality. But what about if you need to test on the embedded device something that is triggered by time or something like that? But Google Test provide any, I can say, tool set for something like that?
You mean about time, but let's say when you have a function that, for example, is counting the time in 1 minute, stop something.
Let's assume this.
Yeah. So basically here we don't, Google Tests don't have something like that, but we will emulate this timer count, because this timer should be saved in some variable, right? Because if you have the timer somewhere in the code, some counter is increasing, okay? And basically what the function is doing, because remember, we are speaking about the functions level. It's not integration, only the function. In this function, some variable will be triggered as, for example, imagine that the limit of the counter is 10. When this variable is 10, the counter is on the limit. Basically, what you have to do is emulate this value. Or let's say, if it's calling another function to got this value, you will stub the function, and when we go to the stub, you return 10. And you will simulate the case when it is on the limit. If not, you can do it inside of your function, to put this value as 10, or using the fixtures we set up and the tear down to clean and do that thing. Because in the level of the functions, is not really as in the integration level, where we have a real counter and it's counting interaction between functions. Here we have only one function, and we set this variable that it's saving the counter value. Yeah.
Yes, it's quite natural. Yeah. Another question regarding the mock state, because you showed that we can assume that, for example, there's a true something somewhere, something like that. What was that?
Yeah.
Yeah, here. So does Google testing in C++ provide something similar to Mojito, but like in Java, that you can build like the whole object of something that you are testing? Because actually here it can work pretty good when we are speaking about procedure programming. Yeah? But when we have the more object-oriented, when, for example, you are triggering some function, and this function is also related with some kind of state in the object of whole class and so on. It's also good to have the whole, I can say, content of this object also working under the hood. Yeah. So that's why the question is like, because it's easy like to put the true somewhere in the code, yeah. And my question is more related with the integration of more code base to the test, yeah.
Yeah, when we are speaking about the object, right? So basically, you can create an object to be under test. Imagine that we have a class that we need some parts of that. We can create a, let's say, object class test and object like this, and use the functions around that. About the mocks, if we have different calls for different things and different services, of course, it's a really simple example, only to be more understandable. But in terms of embedded, we know that we have a lot of external dependencies, communications, a lot of things. And basically, we need to mock all of that and simulate for each one what's expected to be done. And it depends on the test case. Here it's return true, but we could have something like if test case equal 1, 2, 3, return true. Else, if test case is equal 1, 4, 5, 6, return false. And for each different test case, according to the thing that I'm testing, the mock will return different things. Yeah. Thank you for your questions. More questions, please?
Yeah, I wanted to ask, how is this unit testing approach in automotive domain is different from more general domain? Is this because we bound to use the ASPICE or something? There is something different in the approach.
You mean, I'm not understanding well the question. Sorry, if it's different from the other products approach?
Yeah.
Yeah. So there are a lot of common points, honestly. So ASPICE is really focused on automotive, but there are other standards quite similar used in other kind of industries. But as automotive is one of the most popular ones, that they created some specific for that. Of course, and I already did it in some projects, all of that things can be applied in other industries. Of course, good practices, also ASPICE, of course, we need to adapt for the specific industry, but the main principle can be applied as well, yeah. It's not a thing that you say, no, it's only for automotive, and you are not allowed to apply this outside. No, it's not true. You can apply, but that's it. It's dedicated for that, but can be derived for other projects in other areas, of course.
But is the opposite true? You have to use ASPICE in automotive, or you can use other frameworks if you like.
You can use other frameworks, but ASPICE is, let's say, like a stamp of quality on you. ASPICE.
So I can give an example where the ASPICE is applied. For example, in the European Union, yeah, that if you have a driving assistance in your car, they need to have the level 3 of of the standard. Yeah, ASPICE, yeah, because it's the acronym of software, automotive software. I don't remember actually the whole shortcut. Yeah, but for example, if you have there are 5 levels. Yeah, the 5 is like the best. All the requirements are checked. Yes, for example, if you have something that assists you while driving, it needs to have level 3, because otherwise the European Union will not give the homologation. I don't know how to say it in English.
Homologation
allowance that you can use it on the public road. Yeah, but if it's like an autopilot from Tesla, they needed to go through 5. Yeah, so there are something like that. Yeah, and actually
it means that if you want to pass the certification, you have to apply this ASPICE.
Yeah, for example, some kind of stamp for some brands of automotive in Europe or another country say, okay, I would like to work with you, but I want that you have level 3 of ASPICE. And I can add information how it works. You have your process, your project, that things. You call the ASPICE auditor, do the audit with you, check, okay, look the findings, and in the end give you your level. And then you have a possibility to fix the fines and repeat the process on that way. Yeah. But it's a really plus for OEMs in terms of Europe to have a ASPICE stamp, let's say.
Yeah. Which features of the framework, yeah, available else? For example, tear downs, yeah, precondition, postcondition, maybe some, I don't know, listeners, observers, hooks, yeah?
Yeah, we can have something like that. We can have, for example, parameterized tests that allow you, for example, insert, for example, one array of values, one array of expected results, and then we'll run the tests and matching them. This is one example of feature. Of course, I only presented the simple ones to don't be so really deeply in terms of technically to understand the concept. But yeah, there are more features that can be explored here. More questions? Okay, let me check questions here. Okay, we have only questions. So the question is about if I already use it, Copilot or some kind of tool to generate code for me. So I never use it Copilot, honestly, but I already use some tools that generate some code. For example, Enterprise Architect, but it's not for unit tests, it's for more for integration tests, where you put there the architecture of your code, and then it generates for you some interfaces, classes, and things like that. For this case, I never used some tool, but I already implemented some tools to generate to my code. For example, to automate generate mocks, to automate generate some parts of the tests, to test the code structure, the test structure, but some tool that it's possible to buy or use, I never use it. Only tools developed by myself and colleagues that work with me. So I don't know if you have more questions. So if not, rest me say thank you for all of you. It was a pleasure for me Obrigado in Portuguese. It's a pleasure for me to see your interest and participation. Also, your questions are welcome. And if you in the future have questions about some topic and I can help, please let me know. I'm here to support. Okay. Thank you a lot for your presence, and we can close. Thank you.